To you, Santiago Bragagnolo. Okay. Okay. Well, PhaROS. Does anyone know ROS? Just to know about how to manage. Okay. So first of all, I will talk to you about our first scenario. Okay, I'm working on École des Mines de Douai in France. And I'm working in an engineering project that is about solving this problem. So let's suppose, by example, a market or some place that you just arrived and you don't know it, or maybe it has some changes on the layout of the stuff and whatever. So we just picture this guy that is going to just buy wine and fish. Nothing else. So you just go into the shopping and you don't have any small clue about which is the layout of the place. So you just start to go around trying to find something, and you realize that yes, maybe I should buy that cheese. Maybe should I buy flowers for someone? Not me, but maybe. And okay, so in the end, the guy spent 2 hours of his life, a lot of money, and he forgot about the fact that, or maybe he just creep out, say, okay, whatever, I will go home and do not eat anything or eat this crap. So the proposal is to have a guidance robot that aided the persons to navigate an environment that is not pretty known. Or it changed because they changed the organization of the stuff in the market, or maybe it changed because of remodelations, or maybe you just don't know. You just are new in the place and you don't know which is the organization. So the idea is, okay, the guy comes, he has a robot for asking for the things that he needs. Maybe we can make it more flexible and talk about things that I should need or I may need in terms of a bit more abstract. No, I will not tell the robot I want fish and wine because he will point me to maybe a proper fish. I just want to talk in a more abstract way, but whatever, that's implementation. So the idea is to have a robot that will guide me in the best path that he can manage to find, make me pick the stuff that I need, go to the checkout, pay, and go away. So the idea is to take less time to do what we need to do inside the building, and do not spend more money than the money that I need to spend. Do not go to buy something else. I just need to care about my time, because actually I don't like to go into the market. I feel really disgusting when I go into the market. So that's why I like the project, because actually I find myself really related with it. So that are the objectives. Find things. Okay, I forget the part. We need to first make able the robot to recognize the ambient, find things, a product, people, facilities, whatever. So in our scenario now is a market, but actually we have 2 scenarios in test. One is the market, and the other one is an office building or office building. So the idea is to find things in an abstract way. Find the best way to reach them, and so do it. Challenges. Understand the environment. So no, I didn't forget about it. I just put it in the challenge. Okay. Well, understand the environment. That okay, a robot is just a a computer that runs a program and has some capabilities for sense and do something about it. In order to be able to do something about it, we should have a way to understand what we are sensing. So then in order to understand the environment, we need to make kind of a mathematical system. That is called just mapping. That means that we will make a map of the place. In this project, we keep it in 2 dimensions, so it's not that difficult, but it's good. And okay, define things to track and track them. So how do we put something for the robot to understand what is interesting for us and what is not? Avoid obstacles. Actually, when the robot is making the exploration to understand the place, or when the robot is just leading us from one place to the other, we don't want the robot to collide with columns, little kids moving around. It looks stupid, but actually, if the robot is just moving a bit inside the shopping mall, and the kid is just going as hell against the robot, and the kid collides the robot, who has the guilty there? For the parents, because it's what matters. Okay, yes, it's a robot. So, and then, if we are in a shopping mall, it's not just about avoid some static or eventual obstacles, it's avoid a lot of obstacles. And maybe be not able to go through. So, well, that is our project. So, in order to do that in just 1 year and a half, which is the amount of time of the contract, we cannot just do everything. So what we decided to do is to integrate somehow to a platform that already have several of these problems already resolved or easy to integrate in order to resolve our problems. That's why we choose ROS. ROS is a robotic middleware and integration framework. So it's something that will define a way for integrated processes in terms of, I don't know, a protocol, how to serialize the stuff, etc. And it will give us a space of running. How then it imposes an architecture. In order to achieve this integration stuff, we need to have something to integrate and a channel to integrate this stuff, a way to integrate this stuff. So the things that we will integrate are called nodes. The nodes are processes that have some behavior, and the behavior is defined in terms usually of input, and usually it generates an output. What we like in that ROS actually proposed also is to have a lot of small processes that has small behaviors, small responsibilities. With this proposal, the idea is to be able to reuse a lot of processing stuff and to be able to switch one process for another process and change a bit the behavior, or change the implementation and keep the same behavior without having a big impact. Actually, one of the things that is needed in robotics is we need to remember that we have a battery, and the battery has an amount of charge, and that matters. Actually, one of the main deals with the performance is not just the fact of the price of the robot, is also the problem of the battery. The battery should last as much as we can, and it should be predictable. So what happens if the robot is running out of battery? We should be able to put down some services. So how do we put down services? Well, here we just kill a process. That's all. It's quite easy. Okay. Okay. Then that is a node. The topics is the topics is a way for communicating in between different processes. It's about, there are called topics because there are connections about interest. I'm interested in know the pose of the robot each time. So it's a stream of constant information. Yes.
It's publish subscribe mechanism.
Okay.
It's a publish subscribe mechanism.
Yes. Exactly. Yes. And then the services is open. Then the services are for the big stuff, something that that is not related with the main responsibility, but may change some configuration of the node or give some specific service, and it comes with request and response like any service. But the topics does not. It's just one way of communication. But the protocol. So why is that we choose ROS? Because of the existence of already developed software a lot. We have there was already a SLAM algorithm implemented. There was already path planning. There was already collision avoidance, but for not that closed spaces, so we need to make some work over that. It has a growing community that is really active, so you have a lot of easy to get answers, and there's a lot of know-how available, just because of the growing community. So then, FARO, why FARO? Because we are here, right? This lab environment, it has constant innovation. We have, it's amazing the fact that there are always a lot of PhD postdocs and engineering working on the platform. And it has a great programming and debugging tools, set of programming and debugging tools. What will lead us to have a really dynamic prototyping of the nodes, of the process that we want to do. So, we developed PhaROS, which is not a cool name, but we change it. Framework for robotic behavior development based on ROS architecture, high-level abstractions abstracted from ROS installation. That means that we can, if we want, to run a PhaROS node without all the infrastructure of the implementation of ROS stuff, just because it's full inside the box. So this is the robot that we work well with. This is why we didn't need more than 2 dimensions mapping. It's because it's a differential drive robot, so we just care about this movement and this movement, nothing else. This, it will not go up, go down, so we do not care about the third dimension. We just care about the third dimension in terms of sensors, like the camera is where, but that is fixed. So, then we have done in PhaROS the whole controllers for the robot, just for all for moving the robot in a differential way, for taking the laser sensors, for actually we add some sensors extra. This is a sensor for understanding tags, for reading marks in the environment. So that's what we use for tracking places that we care about. It can be better, but it's costly. I mean, we can also put some RFID in different products, so we can make a better lecture of the place. But what we choose is to sectorize and then configure the sectors by hand, which is quite cheaper. For a market, it's not doable because the market changed a lot. But for the office building, it's quite helpful. So then we have also all the third-party and robotic software that is all developed in C++, Python. There are some things done in Java. But since we have everything through TCP connection, which is quite standard. We can run in parallel with all that things without needing to rewrite anything. If we need to rewrite something, we can do it, but for going out of the problem and having a prototype and understanding the problem of the domain is quite useful. So where does my code run? We have there then the hardware, operating system, ROS, FAROS, and our application. We run over FARO and we touch ROS through FAROS. Okay, we already talked about ROS. What do we have in FARO? Okay, our main abstractions are a parallelism of the ROS abstraction. So we have our node, we have our topic replication or service replication. We have a nice way to load and interpret the type definition and make marshalling automatically and generate all the stuff needed for. But that is, we don't have enough time to talk about that, but it's nice to have. So, things that are different with ROS classical implementation. Our image is all processed from outside. Our image is all processed. Usually, when in ROS we have one process, one node. In FARO, we can have actually several nodes inside the same process, inside the same image. And the funny thing with that is that the cost of communication in between two nodes inside the image is almost free. It's just message passing. We have a lot of we have a cool lookup for the channels of communication, and it happens the same for the service call. We have then the service call and inner topic connections are just message passing. Then for the outside, they look and communicate as individual nodes. So why we do this? Because actually what happens is that if we can have all the construction inside the image and it's not okay, perfect. Ooh. Okay, thank you. Okay. Whatever. So then we have also the nodelets. The nodelets are like nodes. They look like nodes, behave like nodes, but are not nodes. They are just seen by us as programmers. We define some logic and we plug it inside the node through dependency injection. And for ROS, from ROS we are just one node more. The funny thing with this is that we avoid a lot of stuff that we need for. Okay, a node needs a TCP server, an XMRPC server. It needs a lot of infrastructure. So if you have inside the same image a lot of nodes with all that stuff related with for each node, it's not good. Not when we have to consume a laser stream, which is something that it has 60 hertz of a lot of bytes. So it's not easy to take it. So okay, that I think the main difference. I would want to talk more about nodelets, but we don't have enough time. So then we have a tool for code distribution. That is actually all of this is MIT license. The code distribution is cool because we have a way for deploying directly for several distributions of ROS with several distributions of FARO, several versions of FARO. And we have, when you need to deploy a new type, you need to make some C code, some special make stuff and whatever. That is all automatized. So you just have the metadata of your project in your project, and we load that from a third tool and install and generate all the things needed for that. It happens the same with the scripts. The script is the entry point of the system. Each script is one node, actually. So we can create new packages with different targets, so based like could array down configurations. And okay, so I will just show you. It's very bad actually. You're never too prepared for this kind of things, because actually I burned my small robot today morning. So sadly I will not be able to show you this one, which is far better than just a small Arduino with a LED. But okay, if he will tell me, if he let me, if he does not let me, will not be able. Okay. What happened?
Oh, you did put it on top of something, which I don't know.
Okay, I made something that. Okay, so switch ROS-core. Okay, ROS-core is running. Started now. We will go for. Okay, just 1 second. So we have an Arduino board, which is quite common and unknown. We have a serial port related, which is always giving me pain. And going to wait a bit for this guy for giving me feedback. No. Very bad. Okay, last. Okay, perfect. And then we have ROS, run, FOSDEM, PhaROS, Arduino. I think it was. So we start, and we have here, or debugging console. Okay, I put the HART here because it's just to be able to manage the Arduino board from here, from the same HART. It has already configured all the stuff.
Yeah.
For
Can we have video of that?
So for doing this, we are starting up one node that is inside, one other node that communicates with this node through a serial streamer, actually, and the third node, which is our node that is just controlling it. So for doing this, I just need to, do this thing, I just need to code a basic cool object that is a LED that has a state for on-off, and that's all. But okay, what I was saying before about debugging tools and cool programming tools is the fact that I can give shape to the node through a debugger, through a debugging session, having the string there in my hand. So I don't need to go to see, okay, which is the shape of this data, which is coming from another node, which is a pretty pain on the ass, really pain in the ass. It's just so easy to develop there, because you have already all the data in your hands. You just can give feedback instantly, just executing a line.
How long is your feedback cycle?
It depends on the. You talk about the. Okay, there are some nodes that need a complete constant feedback. What you do with that is you just spawn it in other thread. But actually, what happens is that you first before having your output to be able to give something, you just need to understand which is the real knowledge that you have from the system. Actually, what happens is that there's a lot of knowledge inside the system because of the different sensors and the different pre-processing of information. So you need to start to play a bit with which is the information that you like more, that you have that's better. Okay. Okay. Okay, perfect. Yes, I think. So, video demo. Doesn't matter. We have a video of the demo of the shopping mall but it's long, so it doesn't matter.
We can have very short questions.
Any questions?
When will you burn your robots this morning?
Today morning. Yeah, you don't know. Yeah, okay, yes. We were having a kind of hangover today morning. If you want, I will tell all the secrets of the morning. You will not be so satisfied with that. I have no problem and no dignity. Yes, I have dignity, but not about that. So, any question?
So, thank you, Santiago.